So what I want to do here is actually walk through the process of determining the volume from a Buret reading. And what you see here is the actual data from the experiment. So I'm going to give you the initial volume for the titration 1. You'll see this image in the video. These images are also posted on the PDF on Moodle, along with the volume measurements for the other 2 titrations. So from General Chemistry 1, you've experienced this to a degree, right? When water goes into a glass cylinder, there's attractive forces, pulls up the sides of the top of the water, okay? And that produces something we call the meniscus. And what I've done here, and I've done this in all the images, is I've highlighted the bottom of the meniscus. Honestly, this is easier to see than what you do in the laboratory. Now notice how the Buret is laid out. It's different than a graduated cylinder, which we've all had experience with. You're starting at 0 milliliters up top. The volume is increasing as you go down. And what you have to realize is that each line there, as you're dropping down on the Buret, it's actually counting up on the volume. So again, each line you're going from 0 to that mark is 0.1 to 0.2 to 0.3 milliliters. And then 1, 2, 3, etc., which you can't see. So this particular measurement, where that bottom of that red meniscus is, notice that it's just past the 0.4 milliliter mark. It's not quite to the 0.5 milliliter mark. It's a little bit more than halfway between those 2 marks. I would call this 0.47 milliliters, 0.48 milliliters. And that's the value that you would want to record on your report sheet. And you do this for each of the images. Okay, so you're going to be recording to the 100th position for each volume measurement in a titration. Remember, typical procedure for measuring from an analog scale, which is what we have here, you're going to estimate the next digit down from the markings that's on the Buret or graduated cylinder, whatever you're using. And since each mark is at 0.1 milliliters, that means you can estimate the 0.01 position.